Okay, so page 11. Okay, let me just do a recap. So we have we're always going to be identifying the shaded region. The shaded region is going to be the enclosed region and then the problem should provide all the boundaries that's going to isolate that enclosed region. So for number 1, we have y equals 2x cubed, that's the curve. We have the line y equals 8, that's the horizontal line. We have the y-axis, which is x equals 0. It says find the volume generated when the shaded region is rotated about the line y equals 8. Anytime we have a rotation, that's about to tell you where that axis of revolution is. So that's where the dotted line is. Okay, so dotted line, y equals 8. We don't have to draw the graph, what the picture looks like, but we have to kind of understand that your axis, it looks like the edge of your diagram, but it's really the center of your diagram, right? After the rotation occurs, this piece is going to be flipped over above the axis. It's going to create kind of a bowl-shaped object that's kind of opening to the left. But we have to understand that that's the center. And because that's the center, to create these radius that we're looking for, we have to always include the center of the object. Okay, so center of the object, y equals 8. Okay, so we have a horizontal axis of revolution, which means that our radius is going to be perpendicular, which in this case is vertical. So whenever you see a vertical radius, typically that just tends to be an easier problem because the equations that's provided for you are largely going to be ready for you to use. Okay, so whenever you see a vertical radius, you just typically know it's going to typically just be a easier problem to set up. Okay, all right. So now that we're here, we know that we have to do top minus bottom because we see a vertical radius. So we look at the top of the radius. The top of the radius is touching the dotted line, which is 8. So that's going to be our top graph. We look at the bottom of the radius. The bottom of the radius is touching the curve, the 2x cubed. So that's going to be the bottom graph. And we always do top minus bottom with a set of parentheses around the bottom, just as a way of protecting so that we don't get messed up with that negative. Now, it's not going to make a big deal if there's only one term, but if there's multiple terms, the negative has to distribute through. Okay, once you have our radius, then we have to put into our formula, big radius quantity squared. We'll put the squared around the entire radius expression. And we're going to find our bounds. Remember, our bounds, in this case, is in terms of x. So if it's in terms of x, we want to find the furthest left to furthest right. So furthest left is 0. Furthest right is wherever the intersection is between the line y equals 8 and 2x cubed. You can use numsolve in your calculator, or you can use your graphing calculator and do intersect and find that intersection. Either way you find that, and then the rest goes in your calculator. Leave pi out of your calculator, okay? And then at the end, you can just attach it to the end of your answer. You're always going to try to get this to be a fractional form if possible, but if it can't get to a fractional form, then just go to approximately 3 decimal places. Okay. You can either write whatever that third decimal place is, or you can have the fourth decimal round the third one up. So AP exam will accept either. Okay, just do something to the third decimal place. Sometimes, yeah, that third decimal place, you can decide what you want to do with it. Okay, did we finish part B? We did. Okay. I'm still going to run through it though, trying to make sure that where we are. Okay, so part B, we're rotating about the y-axis. Anytime you're rotating about a vertical line, just recognize that typically more work is required because the equations are not going to be set up for us. Most of the time, it's not going to be set up. We have to rewrite the equation. So whenever you see a vertical axis and a horizontal radius, that's a bit of a red flag. Okay, just make sure that you don't just blindly use the equation they give you. You have to do something with this equation before it's ready. Okay, right minus left indicates everything has to be in terms of y. So if everything in terms of y, we have to rewrite our equation. This is in terms of x, so this is not ready for us to use. So we divide by 2, take the cube root of both sides. Now that our expression is in terms of y, we can use it. And notice how all these equations are set up. Right? Anytime your x is isolated on the left side, that indicates that the right side is prepared and ready for a right minus left format. Okay. So right minus left, the right endpoint of my radius is touching the curve, and the curve is the cube root of y minus 2. The left endpoint of my radius is touching the 0, so that's the left portion. All right, we set everything up. Our bounds is from 0 to 8, and the reason why is we don't go from 0 to 1.5 because 1.5 is an x value. We're stacking these circular disks from the lowest to the highest y value. In this case, the highest y value is just that line. There's no need to use our calculator. We can just read it from the graph. So enter in your calculator. You may see y on paper, but in the calculator, you're going to use x. And we get 12.095 pi units cubed. Okay, so today we're just going to practice with this method, either horizontal or vertical axis. We're going to practice creating our radius, practice using our calculator to find the bounds when needed. Okay. All right, so we're just going to try to get through these two pages, page 11 and page 12. All right, so take a look at number 2, part A, and see if you can read the problem and decide how you want to start building out your information. I think we set everything up. This should be a top minus bottom function here. Okay. What do we have to be careful about with this top minus bottom for this problem here? Okay, we know the top function is 7, the bottom function is e to the x plus 2, right? Pretty straightforward, but how would you write this? 7 minus what? Can I do this? Is that correct? What do I need? Good, parentheses, right? If you write it this way, you're going to miss out on the fact that this plus 2 is not the correct sign. Right, we need the entire bottom function subtracted from the top. So the parentheses is a big part. Otherwise, it's going to throw your answer off without the parentheses. Okay, bounds from left endpoint to right endpoint. We see the left endpoint being 0, but the right endpoint, it's not very clear, right? So we can set the two functions equal to each other using numsolve in your 36 Pro, or you can graph the curve in a line and find the intersection, or you can set the equations equal to each other and find the intersection. In this case, it's doable to do this out by hand. Okay, there's an act log of both sides. That will allow the x to come down in front. But if you're using your calculator, you can also get that decimal to be 1.609. Okay, so using your calculator or either calculators, let me know if you're having trouble getting to that approximation using the intersect feature. Okay, so everything should be ready for us to set up. My radius, if I clean this up, 7 minus e to the x minus 2. Right, the 2 changes its sign to a minus sign. 7 minus 2 is 5. 5 minus e to the x. Now we're ready to build our volume equation. Practice entering this into your calculator. Leave pi out of your calculator and then just put it next to your answer. Okay, try part B. Okay. What's different about part B and what's going to make this problem a little bit longer? Okay, right minus left, right? Horizontal axis, sorry, vertical axis, horizontal radius means the equation is not ready for us, right? We have to rewrite the equation before we can use it. start on the axis, start on a dotted line, extend to the boundary of your shaded region. Now we're ready for right minus left, but this equation is the curve, but this is not in the right form. So we have to get x by itself. Okay, step by step, right? I can subtract 2 from both sides. Now, e to the x is not good enough, right? We want just the x by itself. So what can I do to get that e to go away? Take the log off both sides. Natural log, right? Natural log allows that exponent to come down. It also allows that allows the natural log and e to cancel each other out. Okay, so the curve is now rewritten in the form that is appropriate. Natural log of y minus 2. The left endpoint of my radius is touching the x equals 0. Okay, we're now about ready to start building our volume formula. Now, look at your radius here. Radius is horizontal, so that means you're stacking these disks from all the way down here to all the way up here. Okay. How do you think we can go about finding this y value here? Okay, we're not going to be able to graph x equals 0 in the calculator. However, that's just the y value at 0. So all you need to do is plug 0 into the function and get that numeric value show up, and that's your y value. Okay, so there's no need to do intersections with vertical lines because you know what that x value is. Just insert that x value into the function, and you can instantly find that y value. E to the 0 is 1. 1 plus 2 is 3. So the lowest that the circular disk is going to go is a y value of 3. Remember, we have to use y values, right? Go back to your formula here. The formula at the top says, if we want to do right minus left, your bounds have to be in terms of y, lowest to highest y value. Okay, the highest y value is easy to see. It's just going to be a y value of 7 because that's just a horizontal line. And then we just do right minus left. Okay, so I forgot to put the radius here. R of y is just natural log of y minus 2 minus 0. Okay. If there's any questions about your calculator or about any steps, let me know. I can come around and answer your questions. All right, let's go to the back page, page 12. Read the problem, draw your axis revolution, decide how you want your radius to extend. And based off your radius, you're going to decide, am I going to do top minus bottom, or am I going to do right minus left? so go through your steps. Okay, I know that sometimes calculators will, some calculators will convert to fractions, sometimes it doesn't, or some just doesn't do it. So for the most part, I will accept 3 decimal places if you can't get into a fraction form. Okay.
Does it matter?
If you want to do num solve, let's see. You want to do num solve between this curve and this line, right? So this is x equals 2. This is x equals, so you would say 2 is equal to that. But make sure you put x for your num solve.
Okay.
So 0 equals cube root of x times 2. Got it. Okay, so this one, you're actually doing this one because y equals 2 is horizontal line. This is x equals 2. So it's okay. I mean, just know that you're solving this problem. Okay. But it's okay. You can just do it. You continue finishing that problem up and then switch over to the other side. Yeah, guys, make sure that y equals 2 is a horizontal line, x equals 2 is a vertical line. Okay, so I saw some students before as well, just swapping it. But if you made that mistake, then just continue with what you were doing and then just switch over to the horizontal for part B. But part A should be horizontal axis of revolution. I'll get a better view. Now you're just telling how they're this curve. Get closer to the intersection. Okay, any questions with part A? All right, try part B. Now part B is going to be a vertical line, right? Vertical line. So once you see vertical line, you have to understand, okay, my equation has to be rewritten, right? I think that's the biggest hang up that I see students make is, not making that adjustment with rewriting the equation. So we always have to rewrite the equation if you do vertical lines. Right? Typically, that's what happens because usually the problem is given to you as set up for top minus bottom, not quite set up for right minus left. Because we're doing horizontal radius, we have to rewrite our equation, solve for x, right minus left, but then our bounds has to be, we have to rethink our bounds, right? We're not stacking these circular discs from left to right, we're stacking them from bottom to top. So we know the bottom is going to be 2, but we got to go all the way up to that intersecting point between the graphs. Now, I think I did it the hard way. I set the two y values equal to each other. I think an easier way to do about doing this is, if I want to find that y value at 2, just insert 2 into the function and get that y value. If you insert 2 into the function, it'll automatically take you to that intersecting point. There's probably no need to have to go through this additional step. You're just inserting 2 into the function, get that y value. Your calculator can't graph vertical lines, but you really don't need it to, right? You just make the calculator find that y, give it the x value, it'll tell you the y value, and that y value is the upper bound. Okay, practice entering into your calculator parentheses around the entire radius expression before you square it. Okay, let me come around to see if you have any questions. That's good, yeah. I think that you can either put it like this or put it like that. That's the same. Either one. Yeah, but sometimes the graph may not give you that notification. So you have to practice getting it. All right, let's go to number 4, part A. Thank you. Okay, any questions with 4A? Okay, try part B. Okay, vertical axis of revolution. Our equations has to be rewritten in a better form. Take that y equals 2x to 1/3, divide both sides by 2, take the, not cube root, right? We want to undo that 1/3, so we raise both sides with 3 as the exponent, y cubed over 2, y cubed over 8, rather, is going to be the curve on the right. The left endpoint of your radius is touching the 0. So y cubed over 8 minus 0, your bounds. Okay. The intersection of at 0, I can just plug 0 into the function to get that y value, right? So 0 in for x, 0 to the 1/3 is 0, 2 times 0 is 0. So that just tells us that the lowest that the graph is going to go is 0. The highest the graph is going to go is 2. Okay. And that's another thing to be aware of. When you do right minus left, not only do you have to rewrite the equation, you have to reorient how you involve the bounds, right? We don't go bounds from left to right. We're stacking these disks from the bottom to the top. So we got to do y values for your bounds. So yeah, there's a lot of places to mix things up when you're doing right minus left, because everything's opposites, right? From what we're used to with top minus bottom. Okay, any questions? Okay, 10 minutes left. I want to do one area problem on page 8. So if you guys go back to page 8, we're just going to do 3b, okay, 3b. I'm going to skip A, and I'm going to tell you what that equation of that line is. Page 8, 3b. Okay. Okay, the line, that equation is 18 minus 3x. That's the equation for that line. Okay, the curve is given to you in the problem, 4x squared minus x cubed. So it says find the area of S. We know that this is going to be a top minus bottom, okay? But what's making this problem a little bit more complicated than your usual just regular top minus bottom? Yeah, there's two regions because the bottom function is not going to stay the same all the way through. Right, there's that dividing line, right? If I do top minus bottom for this first interval, the bottom of my rectangle is touching a different curve than if I were in this region. So I need two values here. And there's also three things I need to look for. I need to look for my boundaries, right? I know one of the boundaries is where the line touches the curve. So we need to find that intersection. We also need to figure out where that graph is touching the x-axis, because that is an intersection. That is a boundary. And we also need to find the x-intercept for the line, because that is also one of the boundaries. So I think the setup with the function is not too bad, but we have to take the additional step to find those intersections. So you can practice using your calculator. Find the intersection between 4x cubed minus x cubed equals 18 minus 3x. You can use numsolve to get there as well. You can also figure out where is this graph touching the x-axis. You can use a 0 feature to help you get there. Solve it by hand or use numsolve. And then you can also set 18 minus 3x equal to 0 to figure out what is this endpoint, what is this boundary there. Okay, so in your calculator, what did you find to be the intersection between the curve and the line up at this point here? Anybody find that intersecting point? Okay. If you do second trace, intersect, you can pick a point that is on the curve, hit enter, pick a point on the line, hit enter, and it should find that intersection for us. Hit enter again. X equals. Okay, so it's all the way up here. Hold on, let me see. I need to find a closer point here. Oh, sorry. 4x squared minus x cubed. Percent. Huh. It's not finding that intersection. It should be at 3. I don't know why it's not giving that to us. Okay, sorry, it should be at 3. The x-intercept here is at 4, and then the x-intercept here is at 6. So from 3 to 4, and then from 4 to 6. Okay, you guys have homework just over 7.2. This is Wednesday's homework. I'll check that tomorrow. And then we'll do washer method, which is just extending this method, but now we're going to have a gap in our circular object.